Math time. All right, we're still on the Chapter 5 test review. Now we're on to problem 5, 6, 7, and 8 on the next page. All right, let's get started. Number 5 says classify the numbers. Okay, don't get too caught up by this verbiage, the words. Basically, all it's saying is take these numbers up here and put them into these boxes down here if they are divisible by the numbers that they mention. So I look at 54. Is it divisible by 5 and 9? Well, it doesn't have a 0 or a 5 in the ones place, so no. Is it divisible by 6 and 9? Well, 6 times 9 is 54, so yes, 54 can go in this box. Now, what it means by some numbers may belong in more than one box means I'm not done with 54 just because I put it in one box. I still need to check and see if it can go in this box as well. So is it divisible by 2 and 6? Well, I know 2 will go into it because it ends in 0, 2, 4, 6, or 8. Then now I just have to check to see if 6 will go into it. So a lot of ways I can do that. I can count by my 6's, see if I land on 54. I'm going to skip up. I know 10 6's is 60. 6 times 10 is 60, which that's bigger than 54, but I'm just going to take 6 away and see if I land on 54. And sure enough, I do. So I know 54 can also go in this box. So that's what it means by some numbers may belong in more than one box. This first number 54 went in this box and this box. Okay, so I'm done with that. And then I check, which boxes will 72 go into? Is it divisible by 5 and 9? No. Is it divisible by 6 and 9? Well, I know 9 will go into it. What about 6? Well, if I do my same strategy I used over here, count up to 60, now I need to get bigger though, so I add 6, that's 66. Add 6 more, that gets me to 72. So yes, 72 will go into this box as well. And then I got to check, will it go into this box? Is it divisible by 2 and 6? Well, we already know it's divisible by 6 because it went in there. It ends in a 0, 2, 4, 6, or 8. So yes, 72 will also go in this box. So now we're done with that number. So you have to check each number against each box. Okay. Again, raise your hand if you have any questions about this. I'll let you finish the final 3 on your own. Just wanted to show you how to do the problem. I don't want to do all of it for you. Okay. Oh, I guess I could leave the 72 in there. Whoops, that's supposed to be a 7. Fix that. 72. Okay, let's look at number 6. James works in a flower shop. He will put 36 tulips in vases for a wedding. He must use the same number of tulips in each vase. Oh, that's our clue. The number of tulips in each vase must be greater than 1 and less than 10. How many tulips could be in each vase? So this part right here, same number of tulips in each vase, that tells us we're finding the factors. Factors of what? Of 36. But it gives a stipulation. The number of tulips in each vase must be greater than 1 and less than 10. So let's first start finding the factors of 36. Well, 1 and the number itself, 1 times 36. 2 times what? 2 times what will give me 36? 18. Will 3 work? Well, 3 plus 9 is, 3 plus 6 is 9. So yes, I know 3 will work. 3 times what gives me 36? 3 times 9. What about 4? Yeah. 4 will work. Oh, whoops, I goofed, didn't I? Not 3 times 9. That's supposed to be here. 4 times 9. So, 3 times 12. Then 4 times 9. There we go, Mr. Music. That's better. 5, 10, 15, 20, 25, 30, 35, 40. Nope, 5 won't work. What about 6? Yeah, 6 times 6 will work. What about 7? 7, 14, 21, 28, 35. Close, but no. What about 8? 8, 16, 24, 32, 40. No. What about 9? Yes, and I already got 9, so I know I am finished. Now, here's all the factors. How many tulips could be in each vase? Well, we can't do the 1 in 36 because the vase must, the number of tulips in each vase must be greater than 1, less than 10. Greater than 1 here, but not less than 10 over here. Greater than 1, but not less than 10. Greater than 1, less than 10. Greater than 1, less than 10. How many tulips could be in each vase? There could be 4 tulips in each vase. There could be 9 tulips in each vase. And there could be 6 tulips in each vase. See, I'm just using the factors left over that are greater than 1, but less than 10. So that's the key. So on the test, it's just going to be a different number, but you're going to be doing the same thing. You're going to be finding all the factors, but then just getting rid of the factor pairs that don't land between whatever they give you on the test. It could be greater than 2, less than 12. And then you would look for all the numbers all the factor pairs that are greater than 2, but less than 12. But in this case, it was greater than 1, less than 10. So this one didn't work. This was greater than 1, but its other factor pair was not less than 10. That's why that one wouldn't work. Okay. And then this one wouldn't work, but these two numbers both met the criteria. Both of these numbers are greater than 1 and less than 10. Both of these numbers are greater than 1, but less than 10. Okay. Notice, though, I didn't list 6 twice because if you have the same factor twice, you only have to list it once. All right. Again, rewind if you need to. Raise your hand if you have a question. Focus, can-do attitude, initiative, listen. Let's look at number 7. Brady has a card collection with 64 basketball cards, 32 football cards, and 24 baseball cards. He wants to arrange the cards in equal piles with only one type of card in each pile. There's that weird, strange wording that tells us we're looking for common factors again. How many cards can he put in each pile? Mark all that apply, so there could be more than one correct answer. So I'm going to erase my previous work up here so I have some more space to write. But now on this problem and on the problem tomorrow, there are going to be 3 different numbers, but you're going to do the same thing with the 3 numbers. You're going to take these 3 numbers and you're going to find the factors of each one. So first I start with 64 and I find the factors of 64. Four times, let's see, 10. Oh, no, 4 will work. 4 times 10 is 40, and then 24. 4 times 8, so 18. Is that right? Let me just double check myself. I get going on these, and you guys know I make mistakes. Okay, 16. No, yeah, not 18. Mr. Music, good thing you double checked yourself. 10. 6, duh. Ugh, Mr. Music. Okay, 4 times 16, sorry. 5, 6, no, 6 won't work. 7, 70, then you go back. Nope, 7 won't work. 8 should work because of 4 and 16, and yes, it will. 8 times what? 8 times 5 is 40. 8 times 3 more, so 8 times 8. 9, will 9 work? No, close, but no cigar. 9. 10, no. 11, no. 12, no. 13, 14, no. 15, 16. Okay, we get back to 16, so we know we're done now. Now, let's look at our possible answers. How many cards can he put in each pile? Well, here we're checking all of these. So will 1 work? Yes, he could put 1. 2 will work. 3, do I see any 3s? No. 4, yep, 4 will work. 8, yeah, 2 8s. 32. Oh, I'm sorry, Mr. Music. Oh my goodness, I got ahead of myself. I apologize. I found just the factors of 64. Some of you are probably already saying, yeah, we already know what mistake you made, Mr. Music. Those who don't, I found the factors of 64 and I stopped. I need to find the factors of all these numbers. It's too late. All right, now I'm finding the factors of 32. 1 times 32, 2 times 16, 3 won't work, 4 will work, 4 times 8. 5, no. 6, no. 7, no. 8, yes, we already got. Okay, now I go to 24. I don't skip over and start trying to answer the problem yet. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5, no, 6 we got, so now we're done. Okay, now I find all the common factors. 1, 1, 1 all the way across. 2, 2, 2 all the way across. No, not 3, 4, yes, all the way across. 8, yes, all the way across. Looks like I got lucky anyways. So 1 was still a yes. 2 was still a yes. 4 was still a yes, 8 was still a yes, but 32 was here and here, but not in the last one. So the only one I would have made a mistake on is that last one, 32. So you guys learn from my mistakes, please. I want you to do well on the test, okay? Double check your answers. That's why I always take a little more time. Luckily, I caught my mistake this time, and I was able to fix it before I submitted my test. So find the factors of all 3 numbers and then find all the common factors, and then you bubble in all the common factors. Okay. All right, let's look at 8. The garden club is designing a garden with 24 cosmos, 32 pansies, and 36 marigolds. Each row will have only 1 type in each row. Ben says he can put 6 plants in each row. He listed the common factors of 24, 32, and 36 below to support his reasoning. So, let's check. 1 times 24, 2 times 12, 3 times 8, 4 times 6, that looks good. 1 times 32, 2 times 16, 4 times 9, what did he do there? 9 times nothing will give you 32. So that has me worried. And then 6 times what will give you 32? Oh yeah, it looks like these aren't factors. 6, 12, 18, 24, 30, 36. 6 is not a factor of 32. So is he correct? Well, first part of that is no. Explain your answer. If his reasoning is incorrect, explain how he should have found the answer. So, no, 6 and 9 are not factors of 32. And then, see, every time I try to put a period, it does that to me. Okay. No, 6 and 9 are not factors of 32. You guys have a little more space. I'm going to have to write on the side. What should the correct answer be? Well, let's see. 1 times 32, 2 times 16, 4. Yeah, 4 is not a factor. Or no, 4 times 8, right? Yeah, 4 times 8, so it should be 8 there. And then 8 is also a factor of 36. Did you do that part right? No, that should not be a factor of 36. 6 times 6 will work. 12 times 3 will work. 4 times 9 should be here. And then the 6 times the 6. So let's see. Well, it looks like the common factor is it 4? 4 is definitely a common factor. So since it is a common factor, we can say he, because it doesn't tell us, it doesn't ask us what was the greatest common factor or anything like that. So we can just say no, 6 and 9 are not factors of, and really we can just say 6 is not a factor of 32 if we wanted to be even more concise. But no, 6 and 9 are not factors of 32. He could have used rows of 4. So we want to prove, not only do we want to show that he was wrong, we want to show that we know what one of the correct answers could have been. Again, he could put them in rows of 2 as well, because 2 is a common factor as well. But just one example of how we know what the correct answer is good enough. All right, thanks again for watching, and I'll see you on the next one.